This is part 1 of the series where we investigate variables. Before we start, let's get familiar with the tools that we will be using. So this is the code part, this is the visualization part, and this is the description and also trace. For the presentation, don't pay attention to description and also trace, so these two, but we focus on code and visualization. If you ever want to try the system by yourself by visiting 01pi.com, then description will be helpful, and also you can observe the trace better. So let's start. The very first statement is int a, where it says we want to have a variable and name of that is a, and its type will be integer. So when we say that, system has two entries, one entry in the symbol table and another entry in the memory. Symbol table entry has the name of the variable, which is a, and also the type of the variable, which is int, and then corresponding memory location is empty or uninitialized. In the next statement, we want to assign 4 into a. So let's do that. So nothing changes in the symbol table, but the memory content is changed from nothing to 4. So this is how you consider this assignment statement. Whatever you have on the right-hand side, get its value or get its content, and then put that content into left-hand side. So far we did two steps, declaration and initialization. We can do that in one single step or one single statement as we do it for b. So it says name of the variable is b, its type is int, the content is 5. We do the same thing for c, another entry in the symbol table for c, another entry in the memory for c. So far we have 3 variables, all of them are integers. Now we want to do assignment. We want to change the content of c with 8. So we find c in the symbol table and find the corresponding memory location. We have 7 there. So remove that 7 and replace it with 8. So that 7 is gone forever. And we have only 8 left there. In the next statement, we'll do the same thing, but this time we'll be using from variable to variable. So a is a variable, and we want to get the content of a, and then store that information into c. So check a in the symbol table. This is my a. So find the corresponding memory location. The content is 4. Make a copy of this 4. Keep it somewhere. Go back to symbol table. Find c. Find the corresponding memory location, which contains 8. Remove this 8 and substitute this copy of 4 here. So now that 8 is gone, and we have 4 there. So at this time, you might be considering if there's any relation between this 4 and that 4. So what happens if I'll change this 4? Would you expect any change in here or the other way around? So let's try to change the content of c with something else, this time with 9. So clearly we expect that that 4 will be written by 9. So the 4 is gone, and we have a 9 here. But the question is, do you expect any change in this 4? The answer is no, because what we did is just get a copy of this 4 and write that down here, and that copy is removed. So the original stays as it is. So far, we were dealing with all integers. Let's try to change that to doubles. What if we have some new primitive type, which is double? So let's declare a double. D is a double variable, and that's the corresponding memory location. Again, declaration has one entry in symbol table, another entry in memory, nothing more. Next statement will be assigning value of 1.2 into d. As we did in this case, a equals 4. What we need to do is just find d in the symbol table, find the corresponding memory location, and simply write 1.2 here. So let's do that. So that's the end of the execution of d equals 1.2. Now we need to be very careful about this part. 1.2 is different than 4 or 5 because it is a fractional part. The integers doesn't have fractional part. And because of that, fractional part can be stored in double, because double means that it can get fractional numbers in it. So let's check that next statement. D is assigned by A. So in principle, we want to get a copy of A and put that copy into D. But the trick is that A is integer and D is float. So let's first apply our rule. Find A in the symbol table, get the corresponding memory location, get the content, which is 4, make a copy of that, and find location D, find the corresponding memory, remove this content, and get the copy of that. So remember, in the copy we have 4. So we want to put 4 in here, which we do. But be careful, this 4 is different than that 4. So this is 4.0. It has a fractional content. So this is what is happening. I have 4, make a copy of that 4, and if you are going to assign that 4 into a double, change this 4 into 4.0, so make it double, and then store that double value for D. That change from integer to double is called casting. So without we realizing it, D equals A, this assignment makes casting. So let's take a look at the next assignment. This time we'll switch the order. On the right hand side we have double. On the left hand side we have integer. So we want to store a double value into integer. So a value with fractional part into a value without any fractional part. In Java you'll get an error message there. Try that out and try to understand why it is so. Another question is that how do we get this 4, 5, or 1.2? They are called numerical literals, and we will be talking about that later on.